Scientists just solved a 60 million year old mystery buried under the North Sea. It was the year 2002, and a team of oil company geologists were sitting in front of their computer screens, scrolling through sonar images of the seabed, when suddenly one of them froze. Right there, buried under 700 meters of rock in the middle of the North Sea, was a giant circle. A perfect ring, almost 3 kilometers wide, sitting quietly in the dark, surrounded by an even bigger ring of cracks, spreading 20 kilometers around it. Nobody in that room knew what they were looking at. But one thing was clear immediately. Something enormous had happened here. Something violent. And whatever it was, it had been sitting hidden under the North Sea for tens of millions of years, waiting to be found. For the next 2 decades, that circle would become one of the most heated arguments in the entire world of geology. Scientists would fight about it in public debates, papers would be written and rejected. A room full of experts would even vote on what caused it, like a jury deciding a verdict. And now, in 2026, after 24 years of confusion, the case has finally been closed. What they found is terrifying. Somewhere between 43 and 46 million years ago, a rock from outer space, about 160 meters wide, came flying in from the west at a shallow angle and slammed into what is now the floor of the North Sea. Within minutes, it punched a hole into the earth, threw up a wall of rock and water 1.5 kilometers high, and then that wall collapsed back down, sending out a tsunami that rose more than 100 meters into the sky. That is over 330 feet, taller than most buildings you have ever stood next to. If this happened today, near the coast of England, it would wipe out entire cities in minutes. This is the story of the Silverpit Crater, the hidden scar of a British disaster that scientists have finally been able to prove happened, and the story of how a bunch of stubborn geologists spent over 20 years refusing to believe it. Let's go back to the beginning, because the discovery itself is honestly stranger than most movies. In the late 1990s and early 2000s, oil and gas companies were mapping the seabed of the North Sea using something called three-dimensional seismic imaging. Think of it like an ultrasound scan, but instead of looking inside a human body, it is looking deep inside the earth. Sound waves are sent down into the ground, and the way they bounce back tells scientists what the rock layers underneath look like. Oil companies do this to find pockets of gas and oil trapped underground. They were not looking for craters. They were looking for money. But in the year 2002, a geologist working with this seismic data, a man named Simon Stewart, spotted something strange buried under the southern part of the North Sea, about 80 miles from the coast of Yorkshire in England. It was a circular structure, sitting nearly 700 meters below the seafloor. At its center was the actual crater, roughly 3 kilometers wide. But around that crater was something even more unusual, a huge ring of cracks and faults in the rock, stretching out across a distance of 20 kilometers. Faults are basically fractures in the Earth's crust, places where the rock has been broken or shifted. Seeing this pattern, with a bullseye shape and rings radiating outward, is exactly what you would expect if something had smashed into the Earth at incredible speed. Stewart and his colleagues nicknamed it the Silverpit Crater, after a nearby fishing ground known as the Silverpit. And almost immediately, the idea that this could be an asteroid impact crater exploded through the geology world. Now, here is where the story gets interesting. Because you would think that if scientists found something that looked exactly like a crater, with a central bump and rings of broken rock around it, everyone would agree it came from space. But that is not what happened. Instead, a massive scientific argument broke out. On one side, you had researchers who were convinced this was a hypervelocity impact crater, meaning it was created by an asteroid or comet slamming into the Earth at several miles per second. The shape matched other confirmed impact craters found around the world. The central peak, the surrounding rings, all of it looked textbook. But on the other side, you had geologists who were not buying it. They pointed out that the North Sea sits above thick layers of underground salt. Salt deposits are unstable. Over millions of years, salt can shift, flow, and even collapse, creating strange circular dips and domes on the surface above it. Some scientists argued that Silverpit was not a crater at all, but just a weird salt collapse structure, something called a salt withdrawal feature. Others thought it might have formed from ancient volcanic activity, gas escaping from deep underground and causing the seabed to cave in. For years, nobody could agree. The debate became so intense that in December of 2009, a room full of geologists at the Geological Society of London actually held a formal vote to decide, once and for all, whether Silverpit was created by an asteroid or not. Picture that for a second. Scientists sitting in a room, raising their hands to vote on whether a piece of space rock hit Britain in ancient history. And when the votes were counted, the impact theory lost. Most of the room rejected it. The official record at the time leaned toward the idea that Silverpit was just a strange geological accident, not a scar from outer space. For over a decade after that vote, the crater sat there unexplained, mostly forgotten by the public, but never fully accepted or fully dismissed by scientists either. It became one of those uncomfortable mysteries that nobody could close the book on. Then, starting a few years ago, a team led by Dr. Eusdene Nicholson at Heriot-Watt University in Edinburgh decided to take another look, and this time they had tools that simply did not exist back in 2002. Newer, sharper seismic imaging technology allowed them to build far more detailed pictures of what was happening underground, almost like upgrading from a blurry old photograph to a crystal-clear high-definition video. With this new data, the internal structure of the crater came into focus in a way nobody had ever seen before. But the real breakthrough did not come from the new images alone. It came from something much smaller and, honestly, almost accidental. Years earlier, an oil exploration company had drilled a well near the Silverpit site while searching for gas. That well pulled up small rock samples from deep underground. Nicholson's team went back and examined those old rock fragments under a microscope. And what they found inside them changed everything. Trapped inside tiny crystals of quartz and feldspar, common minerals found in rock, were microscopic structures that scientists call shocked minerals. This is not something that forms from salt movement. It is not something that forms from volcanic activity. Shocked quartz and shocked feldspar only form under extreme instant pressure, the kind of pressure produced by a hypervelocity impact, when an object traveling at several miles per second slams into solid rock. Nothing else on Earth can naturally create that specific crystal structure except a nuclear explosion or an asteroid strike. Dr. Nicholson later described finding these crystals as an absolute needle in a haystack effort. They were looking through samples from a well that was drilled for a completely different reason, hoping to find microscopic proof buried inside. And somehow, they actually found it. Once they found the shocked minerals sitting at exactly the same depth as the crater floor, there was no more room for doubt. Combined with the new seismic images and advanced computer simulations that recreated the impact from scratch, the team had what they needed. Professor Gareth Collins from Imperial College London, who had actually been in that room back in 2009 arguing in favor of the impact theory, built numerical models simulating the whole event. He compared his simulations directly to the crater's real structure, and they matched almost perfectly. After 23 years of arguing, the case was closed. Silverpit was officially confirmed as an impact crater, and the research was published in the journal Nature Communications, funded by the Natural Environment Research Council. So now let's talk about what actually happened on that day, because once scientists confirmed it was real, they were also able to reconstruct the disaster itself in incredible detail, almost like forensic investigators rebuilding a crime scene millions of years after the fact. Somewhere between 43 and 46 million years ago, during a period of Earth's history known as the Eocene epoch, long after the dinosaurs had already gone extinct, an asteroid roughly 160 meters wide was speeding through space on a collision course with Earth. To put that size into perspective, that is roughly the length of 1.5 football fields, or about as tall as a 50-story building lying on its side. It might sound small compared to some of the giant asteroids we hear about, but when something that size is traveling at several miles per second, size barely matters. Speed is what turns a rock into a weapon. This asteroid came in from the west at a shallow, low angle, not a straight vertical drop, but more of a slanted, glancing strike. At the time, this part of the world was shallow sea, not the deep, wide ocean the North Sea is today. When the asteroid made contact, the destruction was almost instantaneous. Within a matter of minutes, the impact blasted a massive column of shattered rock, water, and debris straight up into the sky, forming what scientists describe as a curtain nearly 1.5 kilometers high. Try to imagine that. A wall of rock and ocean water taller than most mountains, rising up in the sky in the blink of an eye. But that towering column of destruction could not stay up forever. Gravity pulled it back down, and when it collapsed, it did not just fall quietly. It slammed back into the sea, and that collapse triggered a tsunami that rose more than 100 meters above sea level. They are 330 feet. For comparison, that is significantly taller than most skyscrapers people walk past every single day. A wave of that size moving outward from the impact site would have devastated any coastline in its path, drowning everything for potentially dozens of miles inland, depending on the shape of the coast at the time. And this all happened in what is now considered one of the more populated, most heavily trafficked stretches of ocean on the planet, just off the coast of modern-day Britain. Now here's the part that should genuinely give you chills. Silverpit is not just some random discovery. It belongs to an extremely rare and exclusive club. According to the research team, there are only around 200 confirmed asteroid impact craters that have ever been found on land across the entire planet, and only about 33 have ever been confirmed underwater. 33. Out of the entire surface of the Earth, 70% of which is covered by ocean. That number is shockingly small when you think about how many asteroids and comets have actually struck Earth over billions of years. The reason we do not see more craters is not because impacts are rare. It is because Earth is constantly erasing its own scars. Erosion from wind and water, the slow grinding movement of tectonic plates, volcanic activity, and sediment slowly burying everything over millions of years. All of it works together to hide the evidence. Most impact sites simply vanish over time, swallowed back into the planet's surface. Silverpit survived because it got buried quickly and deeply enough, protected under layer after layer of rock and sediment for tens of millions of years, almost frozen in time until modern seismic technology was finally advanced enough to peek underneath and see it clearly. And when you place Silverpit next to the other famous names on that short list of confirmed impact craters, the comparison becomes even more unsettling. The most famous impact crater in the world is the Chicxulub crater, buried off the coast of Mexico, created around 66 million years ago by an asteroid so massive it is widely blamed for wiping out the non-avian dinosaurs and roughly 3/4 of all life on Earth at the time. Silverpit's asteroid was nowhere near that size, and thankfully it did not cause a global extinction event, but it still unleashed a tsunami capable of erasing coastlines and reshaping the local landscape in minutes. There is also the Nadir crater, discovered off the coast of West Africa, and only confirmed as a genuine impact site in recent years as well, showing that we are still finding new evidence of ancient cosmic violence hidden under our oceans, right now in the 21st century. What makes this discovery even more important is what it teaches us about the future, not just the past. Professor Collins, one of the lead researchers, said something after the study was published that really puts things into perspective. He explained that being able to study an impact crater's internal structure in this much detail is incredibly rare and valuable, because scientists cannot easily study impact craters on other planets the same way they can here on Earth. Every confirmed crater we find, especially ones as well preserved as Silverpit, gives researchers real, physical evidence they can use to understand exactly how asteroid impacts behave, how deep they punch into rock, how the surrounding land fractures and buckles, how tsunamis form and travel outward from the point of impact. And Dr. Nicholson himself pointed out that findings like this help scientists predict what could actually happen if humanity ever faces another asteroid collision in the future. This is not just an ancient history lesson. This is a preview of what could happen again, somewhere, someday, and researchers are using discoveries like Silverpit to prepare for that possibility, to understand the real, physical consequences of an impact rather than just theoretical models built entirely on guesswork. Think about how wild the full timeline of this story really is. An asteroid smashes into the North Sea somewhere around 45 million years ago. It gets buried under hundreds of meters of rock and sediment, completely hidden for tens of millions of years, while entire ice ages come and go, while early humans evolve, walk the Earth, build civilizations, and eventually start drilling for oil and gas in the exact same patch of ocean, without having any idea what is sitting just beneath their drill bits. Then, in 2002, almost by accident, while searching for fossil fuels, someone spots a strange shape in the seismic data. For the next 23 years, scientists argue, vote, publish competing papers, and cannot agree on what actually happened. And finally, using upgraded technology and a lucky discovery buried inside old rock samples that were originally drilled for a completely unrelated purpose, the mystery gets solved for good in 2025 and 2026. Two different theories that had nothing to do with space, salt movement, and volcanic collapse are both ruled out. And the impact theory that some scientists believed in from the very beginning is finally proven true, more than 2 decades after they were first laughed out of the room during that vote in 2009. There is another angle to this story that most people never stop to think about, and it is the fact that this crater was found by complete accident, using equipment built for an entirely different job. Oil and gas exploration is one of the most expensive industries on the planet, and the seismic surveys used to search for fuel underground cost enormous amounts of money to run. Nobody sends a survey ship out into the North Sea hoping to find evidence of an ancient asteroid strike. They are looking for pockets of gas trapped in rock formations, something that can be turned into profit. Yet buried inside all of that commercial data was a scientific discovery worth far more than any oil field, sitting there quietly since the year 2002, waiting for someone to notice it. This is actually a pattern in modern geology. A huge amount of what we know about the hidden structure of our planet, especially deep underwater, comes from data originally collected by energy companies for completely unrelated reasons. The rock sample that eventually held the shocked quartz and feldspar crystals, the actual proof that finally ended the debate, came from a well that was drilled purely to search for gas. Nobody involved in drilling that well in the first place had any idea they were pulling up microscopic evidence of a prehistoric disaster. It sat in storage for years until Nicholson's team went looking for it specifically, hoping against hope that the right piece of rock at the right depth had survived and had been kept somewhere accessible. Finding it has been compared by the researchers themselves to finding a needle in a haystack, and honestly, that might be an understatement. It is more like finding one specific grain of sand on an entire beach, buried underground, decades after it was first collected, and knowing exactly which grain you are looking for. It is also worth pausing on just how long this argument dragged on inside the scientific community, because it says something important about how science actually works. Most people assume that once researchers find something as dramatic looking as a giant circular crater with rings of broken rock around it, the explanation would be obvious and immediate. But real science rarely works that fast, especially when the stakes involve completely rewriting the geological history of a location. From the moment Silverpit was first spotted in 2002, all the way to that formal vote in December of 2009, and then all the way through to the final confirmation in 2025 and 2026, this single question stayed unresolved for almost a quarter of a century. Careers were built around opposing sides of this debate. Some geologists spent years defending the salt movement theory, others defended volcanic collapse, and a smaller group kept insisting the impact explanation was correct the entire time, even after being outvoted in a room full of their peers. Professor Collins was one of those people. He was present at that 2009 debate on the losing side of the vote, and he said afterward that he always believed the impact theory was the simplest explanation and the one that best matched the evidence available at the time. It took him and his colleagues more than 15 years after that vote to finally get the physical proof needed to settle the argument for good. There is something almost satisfying about that, watching a scientist who was told he was wrong in a public vote spend over a decade quietly working until the evidence finally caught up with what he believed all along. And here's a detail that tends to catch people off guard the moment they hear it. This is not a story from some remote, untouched corner of the planet. This crater sits underneath one of the busiest stretches of ocean in the world. The North Sea is filled with shipping lanes, fishing boats, offshore wind farms, and oil rigs, all operating every single day directly above the buried remains of an ancient catastrophe. People cross this exact patch of water constantly, completely unaware that 700 meters beneath their boats lies the frozen aftermath of a tsunami that once towered over 300 feet high. It is a strange kind of reminder that the ground beneath us and the seafloor beneath our ships is not some fixed, boring, unchanging thing. It has a violent past, and it is still full of secrets that modern technology is only just now becoming powerful enough to uncover. So the next time you look out at the North Sea, remember that somewhere underneath those waves, hidden beneath hundreds of meters of rock, there is a scar from a disaster that once sent a wall of water taller than a skyscraper crashing across the coastline. It sat there hidden and unexplained for over 20 years after scientists first found it, and for tens of millions of years before that. Silverpit is proof that our planet holds on to its secrets a lot longer than we like to think, and that some of the biggest, most violent events in Earth's history are still sitting quietly beneath our feet, or in this case, beneath the waves, just waiting for the right piece of technology or the right bit of luck to finally bring them back into the light. And if it happened once, off the coast of Britain, in a spot people now sail over every single day without a second thought, it raises one question that is honestly hard to shake off. What else is still buried down there, waiting to be found?